Students, let me introduce myself. This is Dr. Debasish Pradhan, Senior Faculty Assistant Professor of Pharmacy Department with College University. I did my postdoc from USA. I am 20 years of having experience, teaching and research experience at Utkal University. So let us have a thorough knowledge about these action potentials, as this is the basic things in pharmacology, as this is the most important thing in pharmacology. As you know, it is required for the entire pharmacy scientific professional studies. You go to the PhD, you go to the research, you go to the M.Pharm, you have the B.Pharm knowledge, you have the PhD, and you have the postdoc. You have to have this knowledge about these action potentials. So these action potentials usually something that is the potentiality of the nerve terminals, nerve endings, the neuron discharge, the neuron, the voltage sensitive, the potentials inside the muscles. So you see, the action potentials, they are having 4 stages. So before going to these stages, the action potentials usually occurs in the line of the actions targeting drug targeting the channels, drug targeting the molecules. So before those things, the action potential happens. So you see, I have due to the shortage of time or due to lack of time, I have represented a graph. That graphs represent the x-axis and y-axis, and it represents the minus 90 millivolt. That minus 90 millivolt is something that is the potential or the strength of that cell. So side by side, I will be drawing 3 cells where that action potential propagates. So minus 90 millivolt is the strength where the cell are really polarized in the negative way. Got it? So cells are polarized in the negative sense. So minus 90 millivolt. Then when the action potential starts, at the first stage, I will say that is depolarizations. Which represents 0. 0 which represents the depolarizations. That means this one is the 0 or the depolarizations. When the sequence comes, the sequence is like I or somebody pricks my finger, then the sensation travels throughout the way and it reaches to the CNS, and thereafter I tend to know that is the nerve endings are pricked. My nerve endings are pricked. So thereafter, this depolarizations start. Depolarization starts means the sodium channel, they gets activated. You know, this is the cell. I am representing another cell. This is the outer layer. This is the inner layer. Usually, we have the cell, and the normal cell does occur the sodium, potassium, chloride, calcium. So inside the cell, the inner cells or the inside of the cells, potassium represents more. Potassium represents more, and the sodium represents outside more. So here, when somebody pricks, when somebody touches, when somebody stick to my finger, thereafter the sodium channel gets open. Throughout that open, this is a channel, sodium voltage gated sodium channel, and here sodium gets inward. So sodium gets traveling inward, and here the positive ions are more, or they increased more. So with the help of sodium and potassiums are there. So here you can say this is the resting membrane potential. The minus 90 millivolt, I told you that this is the resting membrane potential. So resting membrane potential was minus 90 millivolt. That represents cell does not work or in the resting phase. So after the work starts, minus 90 millivolt, all the cell or the cell, they moving towards this positive ions or positive cations. So positive cations making this channel. This is the channel or the pathway, and that travels like this. So minus 90 millivolt, minus 70 millivolt, minus 50 millivolt, 40, 0. So it's reached up to this 0 phase. So I can say this point is the threshold potential where the things generates over. So this is the threshold potential. This point is the threshold potential where we can say from here that new action potential conducts its propagations, conducts its mode of actions from this minus 70 millivolt. You got my point? So thereafter, from this threshold potential that travels towards the 0 or the positive, the cell, whole through cell, they are getting the positively charging cations. So here the sodium gets in, and with the potassium already represents there. So the cells gets depolarized. So that means this one, the first phase, that is 0, which is depolarized up to 0. Now you see another thing. Here, after the depolarization, the peak gets a valley kind of thing, or the peaks gets repolarizations. Depolarizations gets into the repolarizations. That means it decreasing the, we can see from this figure, that means it decreasing the positively ions or the cations. So here with this represent of the graphs, we can see this one is the plateau stage. This one is the plateau stage where calcium starts working after sodium or the depolarization inflow. Then the calcium, they gets into this they moves into the outer side from the inner side cells. So they gets move the movement of calcium, they comes across the membrane wall from the outer side to the inner side, and the calcium represents more. Here sodium, the sodium phase or the sodium, they gets stop over there, and the calcium represents for a shorter while. For a shorter while, calcium represents over there, and you know when the calcium acts on this plateau, on the plateau stage, that is a minimum point of work, the minimum time for the calcium. Looking at the calcium, potassium, his friend, I can say his friend, potassium represents goes outside. So this is the channel through potassium efflux over there. So potassium efflux represents over here. So when potassium efflux from the inner side to the outer side, then the plateau stage stops over there and calcium channel close, and potassium with the help of potassium or potassium with the help of all these things, they tends to goes on. So therefore the cell is getting negatively charged, or more over they are getting negatively charged. So it is known as repolarized. Repolarized. And the last one, that is fourth. One is plateau, 0 is depolarization, plateau. This one is the repolarization, and the third one is the polarized state. So every action potentials that has a limited time, that is 0.2 milliseconds to 0.4 milliseconds. So 0.2 to 4 milliseconds, within this 0.2 to 4 milliseconds, a rhythm or the action potential, the complete cycle of heartbeat, it happens. So next one is the polar state. So again 0.1 second would be there for this polar state. Here it will say it will feel the things in a proper way, like sodium, potassium, calcium. They will be in a regular phenomena. Thereafter this chloride channel opens, and this will make the cell fully recharged, and the complete cycle ends over there with the help of chloride. That means it will make it the cycle completely negative, because it is the Cl minus. So with the help of Cl minus, then it goes back to this minus 90 millivolt, which is the resting membrane potential. So again I am telling you, just with a highlight, resting membrane potential where the cell does not work, that is minus 90 millivolts. After the breaking of things or the initiation of the things, it goes up to minus 70 millivolts, which is a threshold potential where the things will work, where the things will be moved to the move for propagations. After here, the depolation starts, which represents the 0. That means the sodium through its voltage gated channel comes inside the cell, and it is getting more positive ions. The cell is getting more positive ions. Then for a seconds or for a milliseconds, the plateau stage cover up there. That plateau stage covers, like sodium stops there, calcium inflows regularly for that 0.1 to 0.2 seconds. Thereafter, this repolarization starts, where the potassium continues to efflux, and the calcium and chloride, they will be starting their role. They represent the fourth phase, which is a hyperpolarizations. So this represents hyperpolarization. So depolations, plateau, repolations, hyperpolations, these are the phases of action potentials. From this, we can see how the cells are getting mobilized into the different stages. The action potentials, that represents the various phases where the potentials of these voltage gated cations or the cations or anions, they have the role to mobilize the things in order to make it order or disorder. That means if it is a disorder things, then it will be showing a disease. or the persons will be diseased. So action potential, they have this resting membrane potential, which where this the resting cell resting goes on. Cell resting means the cell is in the process of sleeping or the sitting stage, where cells is in the dormant positions. They have the uh, capacity of getting the things like the cations or ions are in a regular mode or in the good proportions, we can say, which is not a diseased thing, or which will not move to the disease, any abnormal condition of the health. So from here we can see it starts to this minus 90 millivolt to minus 70 millivolt. So here this minus 70 millivolt is the minus 70 millivolt is the threshold potentials. The threshold potentials from where the point the whole process of action potential starts. Action potentials, again I told you before that once it is pricking the things or somebody touch me, then the action potential starts. It propagates that memory to the CNS through traveling a distance with that neurotransmitters and with the help of this voltage gated cations and anions. Here, these cations and anions, they represent like sodium channel. The sodium channel has a good role in making this depolarized state. That means it was in the polarized state and it will make a depolarized. The action potential, you see, this is the channel, assume this is the cell. So cell here, the sodium influx starts from the outer cell to the inner. The sodium, they moves in and they are making positively charged to the cell. So with the help of potassium and the calcium and the sodium, they are getting more cationic things or the more polarized. So the action potential travels through this depolarization. This phase is known as depolarization. From the polarized state, it travels to the depolarized state. That means sodium and potassium, they are represent over here more in this phase, zero phase. Thereafter, it reaches to the positive things, or here it represents from minus 90 millivolt, it travels to the zero, and from there it travels to some extent, that is known as plateau. So in the plateau, after the plateau, the calcium has a role to travel inside the cell, and because the cell has the tendency to make it tough, make it cope up for a regular, to make it regular, or to make the irregular things regular. So that phenomenon starts from this plateau, and now you see this calcium, they tends to get inside the cell. That tends to get inside the cell. They moves into the cell, and potassium. Looking at this calcium role, potassium has the ability to get out of the cell, because the cell has the certain strength to hold. That means, if it is 100 cations and 30, 40, 70 ratio, 30-70 ratio, or the 40-60 ratio. 40 means calcium will be 40 and 60 will be the potassium. Here extra 20 potassium or calcium will be there, then it has to be released, or of the potassium has to be release the things extracellularly. So potassium here after calcium influx, the potassium efflux there to make it the balance. So that is known as repolarized. That means first it was depolarized, then the plateau stage happens for zero point 0.1 to 0.2 milliseconds, then thereafter repolarization happens. In the after the repolarizations, the polarized state comes, or the phase 4 stages, that is known as polarizations. So polarizations followed by this hyperpolarization. Hyperpolarization is something like the chloride channel. It has a big role in destabilizing those repolarizations, and chloride channel, they tends to release, or the tends to flow from the outer side to the inner side and make the cell negatively charged. So it has the ability to make the cell negatively charged. So this is done as hyperpolarizations. So here again one more thing is there, that is the enzyme. The sodium potassium ATPase enzyme, they have the biggest role in making this hyperpolarization or the release of chloride channel into the cell. So this one is the fourth phase. So in this figure or whole episode of this class, we can see, so resting membrane potential, that is minus 90 millivolts, minus 70 millivolt, that is threshold potential where the process begins. Then it comes the depolarization where the sodium has the ability to defunction the cell. So that is depolarizations. Then the plateau stage comes where cell takes some rest. Thereafter the repolation happens with the help of calcium and the potassium. Repolation happens again, it will be followed by this hyperpolarizations. So with this I am concluding this session. Thank you.